Welcome back to the channel. It's been a minute since I've recorded because maybe unbeknownst to you, maybe you are aware, I tend to bulk record and then get busy or explore some other ideas and then sort of start recording again. And so it just so happens that I recorded most of March, most of the videos you've seen over the past several weeks, about a month ago or 2 months ago. And now I'm back in the cycle of recording again. And this was interesting because as I was looking for my next topic, as I've been exploring a lot of different areas, I wanted to talk about group by, but then I recalled I had a piece of code that I wrote a long time ago on this topic. So I have a folder of ideas and some code snippets, and I pulled this up, and this was a great starting point for demonstrating the power of group by. And then I believe at the time I wanted to also discuss this method called this Pandas method called Qcut. And so I pulled this out. I'm like, okay, this is a great starting point. And then I was immediately taken back by something I wrote in this code that really violates part of the idea of Pandas, this idea of vectorized data analysis. And I will give you a few seconds to find it, and then I will show you and we will address this. Okay. If you need more time, pause the video. But I will walk you through this notebook and we will explore ways that we can improve this code cell here. So I have imported my libraries, Pandas, NumPy, Seaborn, Matplotlib. So that's some of the typical data processing libraries. I'm running this command here to improve the resolution of my figures. And there is a future warnings that pop up as these libraries are updated. So I'm just going to suppress that warning with this line here. So what I'm doing is importing the iris dataset using Seaborn, load dataset iris. And then what I wanted to demonstrate in this video originally was two ideas. One was the ability to use this Qcut or this quantile cut to form discrete variables of our continuous variables. And then I was going to go on and show the group by method and how we can use that for data visualization or understanding our data set even more. And so I'm going to do that, but first we need to detour and fix the code in this cell. So one of the major outages here is this row of data here. So let me run the cell and show you what we were aiming at. So the idea was to sum up the sepal length with petal length and width to then get the lower quantile and the upper quantile and label that as small and large. And so what Qcut wants, if you look at this coding hint here, is a list of values. And then we could pass in a Q value for the quantiles and the labels so that we can label whatever our quantiles are. So in this case, I wanted to demonstrate how we can create a new variable by summing up all of our numerical variables. And then I did that by using this iterose method, this pandas method here. And this is really reserved for very special cases where you can't quite vectorize the approach. And so when I read this, I'm like, well, all I'm doing is summing up the values for each of these rows and I'm selecting D types. So why did I create this list when I could just use a vectorized set of approaches to do this exact same transformation? Otherwise, this Qcut method is fine. And then I'm saving that as a new column called size bin because I'm binning these variables. And then I return the first 5 rows of data. So let's tweak this code a little bit and make this more Pythonic. To do that, let me reload the data set. And in this case, I'm just going to call it df1 just for clarity. And you can see where we start. So if we run this, we have our original data set. And the first thing I want to do is just select the numerical columns. So we could just do select D types and just select number. And this would just return the columns where the data type is either a float or an integer. And so we can just use this to catch both of those data types. And what I was doing in the list coverage was just summing up these quantitative variables. And so to do that, I could just pass in sum, axis equals 1, run that, and I get the values that I was trying to get here, but in a much more Pythonic way. And so I can continue this analysis as I was showing before. So what I was doing was now using pd.qcut, and I was passing in this array here. That is this set of data here. And the next thing I was passing in were my quantiles. In this case, my quantiles are 0 to 0.5. So the lower 50% of the data and the upper 50% upper half of the data there. And then I can pass in labels. So if we're in the data and we have three numbers, we essentially have a bucket for the lower two values and the middle point and the high value. So we have two buckets that are captured in this range. And so we can pass in an argument called labels and set that in this case to small and large. And so this is what many folks would call refactoring the data. We're making this code more efficient. We're improving it in a number of ways. And I could just set this to df1 size bin. And just like that, we have refactored our code, df1.head. We run that and we get the same output as before, where we are just capturing these smaller flowers based on the length and width of the sepal and petal and the larger values. If we want to just sample this, we could just run df.sample, pass in some value. We could just sample 5 random rows. And you can see that based on the species, we will get a different size bin, either it's large or it's small. In this case, we can pass in many others, but this is just a very convenient way to make discrete variables from continuous variables, and this can help with your data visualization. This could be new features for your models and a very useful way to explore your data. So what I was originally wanting to demonstrate was the power of group by, a way to aggregate this data table based on these respective variables. So let's continue. We can use df1 or df. They now are the same data frame as far as the values that are represented therein. So we'll just choose df1, and we can use the group by method. This is a great technique, again, for aggregating our data. And in this case, let's start off by aggregating with size bin. And so we can just pass in this column, size bin. And if we run this as we will get this generator object. And so as part of the group by, we've told the data how we want to aggregate, but we need to tell it how to bring these values together. And so we can use any number of variables. In this case, I just want to take the mean, and I'm not going to specify a specific column, but in here, I will just pass numeric only equals true. And so it will ignore this species column, as this is of object data type, not a numerical data type. And we can return the mean value for each of these columns based on our group by variable, in this case was size bin. Now, the nice thing is we can group by multiple variables at once. We just pass in our argument as a list, and we can group by, let's start off with, we'll do size bin, and let's also group by species. We will continue numeric only, even though at this point there are only numerical values left. And we run this, you see we have our multi-level index, we have our size bin and our species. And in this case, we see for Setosa, there are no large flowers as we've defined our large bins as we've defined it, but we do have it for the others. So we can already see visually in this table how a model might predict whether we have Setosa versus the other two species just by looking at the size of this. And so a very simple feature that we've created, and we can already see the impact on our analysis. Now, if you don't want this multi-index, we can use the as_index equals false, and that will reset the index, and we will just have our table filled here. Another option in many cases is you'll see a lot of folks use reset index here and get the same outcome. So either way, you have multiple options. It's also really beneficial to consider, depending on the structure of your data, stack and unstack. As we have these multi-index values, we can combine these with many other methods that I've already demonstrated on the channel for analyzing this type of data. And I hope this was helpful. Now, one of the other things that we can do, if you go back to just our bin size, we can pass this as a chain into other methods as well. So let me just add the parentheses so I can break these up over multiple lines. So we have our group by, let's compute the mean, but we can also, if we run this here, we can also begin plotting our data. So we can just add a plot method here. Let's set kind equals bar and run this. And so here, if we just plot this as a bar plot, we can see that for the small bin of data, we have our 4 bars for our petal length and width and our sepal length and width, and same for the large. So there's lots of things we can begin to do by aggregating our data, creating new features, on trying to understand it even more as we explore our data set and look for novel insights. If you found this video helpful, click subscribe. I've got more projects that I'm working on that will expand on these ideas, build them more into the chemistry field. And so if you want to be aware of that, like, comment, subscribe, and I'll see you in the next one. Peace.